If you've ever really watched a honeybee colony, it's just this swirling, buzzing city of tens of thousands of individuals all moving together like they're in perfect sync. But it begs the question, right? Who's in charge? Who's calling the shots? Well, the answer, according to biologist Thomas Seeley, is as brilliant as it is shocking. Absolutely no one. And figuring out how that's even possible, well, that reveals this profound wisdom that's hidden deep inside the hive. So that's the central mystery we're diving into here. How in the world does a colony manage to scan miles and miles of countryside for flowers, assign its workforce with what seems like perfect efficiency, and keep its internal temperature just right, all without a CEO, a manager, or any central command? It's this incredible paradox, simple parts creating unbelievable complexity. Okay, so the key to understanding all of this is you've got to stop thinking about a single bee. Instead, you have to think of the entire colony as one single living thing, a superorganism. In the world of bees, it's the survival and reproduction of the hive that's the name of the game, not the individual worker. Natural selection itself has shaped the whole colony to be this one finely tuned machine. And here's a wild analogy to help that click. Think of a worker bee who almost never reproduces, like a skin cell or liver cell in your own body. Genetically speaking, it's a dead end. It works selflessly its entire life, not for its own benefit, but for the reproductive success of the whole organism. In this case, that means working so the queen can pass on the colony's genes. So if the colony is the organism, what are the individual bees up to? Well, they aren't just mindless drones. Not at all. Each worker has this incredibly rich and varied career. But here's the thing. It's a career she doesn't choose. It's all determined by a biological clock that gives her a brand new job almost every week of her life. A bee's resume is basically written by her age. It's a concept called age polyathism. When she's young, she starts with the basics: housekeeping, cleaning out cells. Then, as she gets a little older, her glands develop to produce royal jelly. So, boom, she becomes a nurse bee. Later on, other glands kick in for making wax and processing honey, and she becomes a food storer. It's only in the final and most dangerous phase of her life that she graduates to being a forager, heading out into the big wide world. And get this, a bee's body is literally a perfect multi-purpose toolkit. Her anatomy actually changes to fit whatever job she's doing at the moment. For instance, those glands in her head, they'll first produce this protein-rich food for the larvae, but later in life, they'll switch gears and start producing enzymes to turn nectar into honey. She is physiologically programmed for every single stage of her career. So who's managing this unbelievable system of labor? It's got to be the queen, right? Nope, not even close. She's not a ruler. She's the reproductive engine of the colony, laying up to 2,000 eggs a day. Her scent, her pheromones, they basically just signal, hey, I'm alive and well, but she isn't directing traffic or telling a single bee what to do. And that just makes the mystery even deeper. If there's no boss, how is there any order? Well, the order doesn't come from a single conductor. It comes from the symphony of communication itself. The bees coordinate everything through this amazing, decentralized network of information that is constantly flowing through the hive. Let's think about it this way. In a typical company, a CEO makes a decision and orders flow down the chain of command, right? Top down. In a hive, it is the complete opposite. It's a bottom-up system where thousands of individuals are just responding to local information, and their collective actions create this intelligent, colony-wide behavior. And the most famous example of this bee communication is, of course, the waggle dance. Now, it's not just some cute little wiggle. It is a sophisticated, symbolic language. When a forager finds a fantastic patch of flowers, she doesn't keep it a secret. She flies back to the hive and performs this dance to recruit her sisters to that exact spot. And this is how it works. The dance happens on a vertical honeycomb inside the dark hive. The angle of her dance, relative to straight up, tells the other bees the angle of the food source relative to the sun's position outside. And then, the longer she waggles her abdomen during that straight part of the dance, the farther away the flowers are. It's basically a living GPS. Incredible. But the waggle dance is just one piece of this puzzle. So much of the hive's intelligence comes from these subtle, indirect cues. For example, if a forager comes back with a full load of nectar and she has to wait a really long time to find a food store bee to unload it, that's a signal. It tells her the hive is swamped. So she performs a special tremble dance, which tells other bees to stop foraging and start helping process the nectar backlog. It's a whole system of these elegant, self-regulating feedback loops.
So what's the result of all this decentralized coordination? Well, you get a foraging operation that is nothing short of a superpower. Get this. A single honeybee colony can effectively monitor and exploit an area of over 100 square kilometers. Now, to put that into perspective for you, that is roughly the size of the entire city of Paris. That's a massive territory for such tiny creatures to cover every single day.
And to cover that territory, the numbers get even more staggering. A forager bee on a single 6-kilometer trip travels 400,000 times her own body length. For a human, that's like flying from Boston to Washington, D.C. just to grab lunch. And they do this over and over and over again. Over a full year, all that work adds up to some seriously huge numbers. A single colony might gather 120 kilograms of nectar and 20 kilograms of pollen. A lot of that nectar gets turned into about 20 kilos of honey, which is the critical energy reserve they absolutely need to generate heat and survive the winter. And this system isn't just powerful, it's unbelievably fast and agile. In one famous experiment, scientists switched the locations of a really good sugar feeder and a pretty bad one. Did the colony miss a beat? Not at all. Within just 4 hours, it had completely reallocated its entire workforce, abandoning the now lousy source and absolutely swarming the new best one. So, after all this, what are we supposed to take away from this incredible display of collective intelligence? What are the big lessons from the hive? Well, as Thomas Seeley himself puts it, none of this is an accident. We're talking about millions of years of evolution fine-tuning these mechanisms. The hive is truly a masterclass in how to build a successful, cooperative group that works. So these are the core principles of the hive's wisdom: a clear division of labor based on age, completely decentralized control, layers of both direct and indirect communication, and constant feedback loops. This isn't just a random collection of traits, it's a time-tested recipe for a highly resilient and adaptive system. So the crucial point, the big idea behind all of this, is that you don't need a group of geniuses to create a genius system. The truly astonishing adaptive intelligence of the honeybee colony emerges from thousands of pretty simple individuals, each one just following a relatively simple set of rules. The intelligence isn't in the bee, it's in the system. And that leaves us with a pretty fascinating final thought, doesn't it? From computer science and logistics to how we run our businesses and organize our communities, we are constantly trying to solve complex problems. If 50,000 bees can do it so elegantly without a single manager in sight, what could we learn from their wisdom?